Just a little cap of yesterday's lesson since there was not a video. We're going to start off by evaluating absolute value expressions. I'm going to give you a value for the variable. You'll replace it in and then you'll simplify. We've done this without absolute value. Now we'll do it with absolute value. We're going to take this expression here and substitute x with -2. And we'll add 1, find the absolute value of that, and subtract 3. Well, this is -4 plus 1, absolute value minus 3. The absolute value of -3 is 3, and 3 minus 3 is 0. So when I simplify this expression, the result is 0. Let's use -2 again in this second expression. The absolute value of -2 minus 3, and then we'll add 5. Well, remember that this tells us to add the opposite. That's our rule of subtraction. So we're going to get the absolute value of -5 plus 5. Well, the absolute value of -5 is 5, and we find the sum, and the end result is 10. On to equations. When we solve an absolute value equation, the key to this is solving twice. We need to remember that when we're doing this, we're going to get two possible answers. When we substitute it in, what fits within that grouping can either be a +9 or a -9. So x plus 4 equals 9 is one possible solution, and the x plus 4 equals -9 is my second. We'll subtract 4. We'll get x is equal to 5. Let's subtract 4 again. And we see that x is equal to a -13. Two possible solutions. If we look at our next problem, it's a two-step, and I'm going to have 2x minus 1 is equal to 17. And remember, I have to do it twice, so I have 2x minus 1 is equal to a -17. Since it's a two-step, we'll first add 1 and divide by 2. And we get x is equal to 9. The second part of this is to add 1 once again. I've got 2x is equal to -16. Divide by 2. Second solution, x is equal to -8. If you take the time to check, both of those will be either the positive or -17, and it'll work. The second key thing to remember when solving absolute value equations is that we need to be sure that we have isolated the absolute value expression before solving. So since there is something added after the absolute value expression, we're going to subtract 3 on both sides. I'm going to get x minus 5, absolute value is equal to 8. Now I can go ahead and solve. Once it's isolated, then we're good to go. We go ahead and add 5 to both sides. X could be equal to 13. Add 5 on the other equation. X could also be equal to -3. One last one. Now, look carefully because this expression is multiplied by 2, so we're going to divide both sides by 2. Canceling here, I get the absolute value of x plus 1 is equal to 10. Now we can solve. X plus 1 equals 10, and x plus 1 equals the -10. One inverse operation, x is equal to 9, and x is equal to -11. And that's all there is to absolute value equations and expressions. We moved on briefly yesterday to starting to talk about ratios and proportions. We found out that ratios are a comparison of two numbers by division, and there were 3 ways to represent it: with the word to, with a colon, or written with the fraction bar, the division symbol. Now, equation states 2 ratios are equal. That is called a proportion. So we're going to be looking at both of these in just a moment. When we talked briefly yesterday about ratios, if you recall, I did something briefly, maybe it'll be different than yesterday, but I had some sort of diagram with some shapes. And with these shapes came some questions for us to complete. This one is definitely different than the one we did yesterday. And hopefully we can see that those are little triangles down there. Okay, so let's write the ratio. Write a ratio for, let's do squares to triangles. Well, there's 1, 2, 3 squares, and there are 2, 4, 6 triangles. Like any ratio, which it represents like a fraction, we would simplify that's a 1 to 2 ratio. Let's now look at the ratio of circles to squares, where there are 2, 4, 6 circles and there are 3 squares, so that's a 2 to 1 ratio. I might just do one more. Let's do the results of triangles to the total number of shapes. So the triangles is 6, and then I've got 2, 4, 6, 8, 10, 12, 13, 14, 15. All right, so that is 15, and then I simplify that by dividing by 3. And there you have your ratios in lowest terms. Now we're going to talk about where the ratios are equivalent by expressing them as ratios that are in lowest terms. So we'll simplify them first. If I look at 6 to 9 ratio and a 4 to 6 ratio, if I take 6 over 9 and simplify it by dividing by the GCF, if I divide by 2, and I divide by 3, and divide by 3, I get 2/3. If I take my 4, 6, and simplify by dividing by the GCF, which is 2, you see that these two are the same, so these are equivalent or equal. So that's one way to tell if two ratios are equal, is by writing them as fractions in lowest terms and comparing. Here are just a couple more. Again, remember we're going to divide by the GCF. So if I divide by the GCF here, which is 2, I'm going to get 3/5. Divide by the GCF here, which is 4, I get 1/2. These are not equivalent. 4, 6 simplifies to 2/3. 6 over 10 divided by 2, I get 3/5. These are not equivalent. 3/5 is already in lowest terms. Let's simplify this. Divide by 3, divide by 3. These are equal. Let's take 15/20 and let's divide by 5 and get 3. 3/4 and divide by 1 and 1, divide by 4 and 4. These are not equal. So again, one way to test out if two ratios are equal is by first writing them in lowest terms. More often, we use cross multiplication. There are special names for the terms in a proportion. The outside two terms are called the extremes, and the inside two are called the means. And these are written as ratios as fractions. It's a 2 to 6 ratio to a, 2 to 6 as 1 to 3. These are the extremes, 2 to 3 and 1 to 6. Now I can see if they are equivalent by cross multiplying. Well, 2 times 3, does that equal 1 times 6? And the answer to that is yes. So these are equal. What did we use? Cross products. Multiply the extremes, 2 times 3, times the means. In a proportion, the product of the extremes is equal to the product of the means, which we just showed. Another way to determine whether two ratios form a proportion is to use these cross products, which means cross multiply. If the cross products are equal, then the ratios form a proportion. So let's cross multiply. Let's try a couple of these. We'll take 4 times 7, our extremes, and we're going to see, does that multiply to equal 5 times 6. So it's kind of a question mark. We're not sure yet. Well, this gives me 28, and this side gives me 30. These are not equal, so that this is not a proportion. Cross multiply. We're going to take extremes. 3 times 8 times 4 times 6. Well, 3 times 8 is 24, and 4 times 6 is 24. These form a proportion. This is true. Once again, multiply the extremes. I've got 9 times 8, and then I have 6 times 12. Well, I have 72 equals 72, which is equal. This forms a proportion. So we're going to see that in order to find if two ratios are equal, we're going to do the cross products. Now, there's more to it than this because we're going to start putting variables in since we're dealing with algebra. We'll do one quickly. What if we wanted to solve a proportion? We're missing one of the terms. Let's cross multiply. When we cross multiply, we get 5x is equal to 30. We'll divide both sides by 5, and the missing term is 6. We'll do more in class, but that's enough to get you started. See you in class.